Have you ever looked up at the night sky and wondered why stars seem to twinkle? It's a captivating sight, these tiny points of light shimmering and dancing against the dark backdrop of space. The stars themselves aren't actually twinkling. This mesmerizing effect is actually a result of the way their light interacts with our planet's atmosphere. Imagine gazing up at the cosmos on a clear night. Countless stars dot the sky, each one a distant sun blazing away in the vastness of space. But as we observe them from Earth, something peculiar happens. The starlight, having traveled for unimaginable distances across the universe, encounters the turbulent layers of our atmosphere. This encounter with our atmosphere is what gives stars their characteristic twinkle. Join us as we delve into the science behind this celestial phenomenon, exploring how the Earth's atmosphere acts like a giant lens, bending and scattering starlight to create the twinkling effect we observe. Get ready to unravel the secrets behind the captivating sparkle of the stars. As we journey through the cosmos, we'll uncover the fascinating interplay of light and atmosphere that makes this celestial dance possible. So, buckle up and prepare for a cosmic adventure as we demystify the twinkling enigma of the night sky. To understand why stars twinkle, we need to first understand how our atmosphere affects the light that reaches us from space. The Earth's atmosphere is not uniform. It's made up of different layers, each with its own temperature and density. Think of it like a giant layered cake, with each layer having a slightly different texture. As starlight enters our atmosphere, it encounters these different layers. When light passes from one layer to another with a different density, it bends. This bending of light is called refraction. It's the same phenomenon that makes a straw appear bent when you place it in a glass of water. Now imagine starlight passing through our atmosphere's layers, constantly being bent this way and that. This constant bending scatters the starlight, making it appear as if the star itself is twinkling. But the story doesn't end there. Our atmosphere isn't static. The air is constantly moving, with warm air rising and cool air sinking. This creates turbulence within the different atmospheric layers. Think of it like looking at a penny at the bottom of a swimming pool. The water in the pool isn't still, it's constantly moving. This movement causes the light from the penny to bend and dance, making the penny appear to shimmer and move. Similarly, the movement of air in our atmosphere causes the starlight to constantly change direction. This continuous shifting of the light's path is what we perceive as twinkling. The star's light reaches our eyes from slightly different angles from one moment to the next, making it look like it's changing brightness and position. This atmospheric dance of light is a continuous process, happening every moment that starlight travels through our planet's protective blanket of air. You might be wondering, if starlight is affected by the atmosphere, why don't planets twinkle as much? It's a good question. The answer lies in the way we see stars compared to planets. Stars are so incredibly far away that they appear to us as tiny points of light. This means that the light from a single star is a very narrow beam by the time it reaches Earth. When this narrow beam is refracted by the atmosphere, even a slight change in direction can cause it to appear to flicker or change brightness. Planets, on the other hand, are much closer to us than stars. This means that they appear as disks of light, even though these disks are still very small to our eyes. Because the light from a planet comes from a larger area, the scattering effect of the atmosphere is averaged out. While the light from different parts of the planet's disk might be refracted slightly differently, the overall brightness of the planet remains relatively constant. This makes planets appear to shine with a steadier light. So, the next time you look up at the night sky, remember that the twinkling of stars is a testament to the vast distances they travel to reach our eyes and the dynamic nature of our own planet's atmosphere. The intensity of twinkling can vary depending on a couple of factors. One is atmospheric turbulence. On nights with a lot of air movement, the twinkling will be more pronounced. This is because the starlight will be scattered more, leading to more noticeable changes in brightness and position. Another factor is the clarity of the sky. On a clear night with low humidity, there's less scattering of starlight, so the twinkling might be less intense. However, even on clear nights, the basic phenomenon of twinkling will still occur due to the refraction of light in the Earth's atmosphere. So, the next time you're stargazing, pay attention to how much the stars are twinkling. It can give you a clue about the atmospheric conditions. The twinkling of stars, a captivating celestial dance, is not an inherent property of the stars themselves, but rather a fascinating interplay of light and our planet's atmosphere. As starlight embarks on its epic journey across the cosmos, it encounters the Earth's atmosphere, a dynamic and layered shroud of gases. This atmospheric encounter sets the stage for the twinkling phenomenon. Light from distant stars, appearing as pinpoints in our night sky, is refracted or bent as it navigates through the different densities of air. This bending, coupled with the constant movement of air within the atmosphere, causes the starlight's path to continuously shift. The result? The starlight reaches our eyes from slightly different angles from one moment to the next, creating the illusion that the stars are twinkling. So, the next time you gaze up at a starlit sky, remember that the twinkling you observe is a testament to the vast distances starlight travels and the dynamic nature of our own planet's atmosphere.